Okay, this is our second video, and these are going to cover problems 10 through 15. So the first one is I've got to find all the equations that will actually cause this one right here to work. Now, I want to know which ones can be used to solve for x. Well, one thing you should always do is first try to figure out any angles that are missing if you can. Because I know the sum of the angles in a triangle add up to 180. So this is 67. So if I did 180 minus 67, I get 113. Okay, so now I want to start thinking about different rules we can use. Well, one rule that I can use is law of sines. So remember, for law of sines, it's sine of an angle divided by its opposite side. So sine of 25 over x equals sine of 113 over 11. So that one works for this one. Now, I could have looked at this guy over here and thought, okay, maybe that works. Sine of x over 25, well, that's not an x right here, so that's only if I'm finding an angle. Tangent I can't use. I don't have a right triangle. Again, I don't have a right triangle, so I can't use this one. So it leaves me with this one also, which may be my only choice. So this is actually using law of cosines. So law of cosines. We look at the three pieces that are together. So x is by itself, and then these pieces are together. And for law of cosines, it's the one that's by itself. It's almost like Pythagorean theorem. So x squared equals 11 squared plus 8 squared minus 2 times 11 times 8 times the cosine of the angle between them, which is the same kind of an answer as E, just different order. Okay, now I want to find all functions that are equivalent to this one. So if you look at the forms of answer, one is like in factored form, the other one's in vertex form. So it doesn't matter which one you want to do first. So I'm just going to factor it initially. So if I can factor out a 3, so I get 3x squared minus 4x minus 5. Then this factors 3x minus 5, x plus 1, and that's this one. Okay, the other one I would do by completing the square. So if I'm completing the square, my first step would be to add 15. Then I'm going to factor out a 3. And leave an open spot. Now, I'm going to take half of negative 4, that's negative 2, and square it. So I added 4. 3 times 4, I've got to add 12, because I added 12 to this side, I've got to add 12 to the other side. Now, this gives me y plus 27 equals 3 times x minus 2 squared. So I get y equals 3x minus 2 squared minus 27, and that was C. Okay, for our exponential function, we have the x-axis is an asymptote. That's why it says y equals ab to the x. There's no like plus k or anything else. So I'm going to plug in for x and y and use that to figure out what the equation is. And once I know what the equation is, I can plug in to figure out what my answer is. So x is negative 1, y is 3. So I got 3 equals ab to negative 1. Then for the other equation, I have x is 1, y is 48. Be ab to the first. This one I can rewrite as 3. This is 1 over b, so a over b. So I get 3b is equal to a. Well, I'm going to use substitution to substitute back in. So we've got 48 is equal to 3b times b. So I get 3b squared. Now I'm going to solve for my b. So divide by 3, that's 16. Take the square root, and you normally do plus or minus 4, but bases on exponential functions are always positive. Otherwise, it's not going to be a function, because you end up getting things like complex numbers, which throw things off. So b equals 4. Now I got to find out what a is. Well, a would equal this 3 times 4, so a equals 12. So I've got y is equal to 12 times 4 to the x. But this was f of x, so now I'm going to plug in 1/2. So f of 1/2 equals 12 times 4 to the 1/2. 4 to the 1/2 is square root of 4. So we've got 12 times 2, and that's 24. So my answer in this case was A. Hey, question 13. Okay, so on this graph, I can see that we have a double root at -3, a single root at 0, and a single root at +3. I see it's flipped over, but that tells me that I know my a value is going to be negative. So just as a kind of a general form, I've got y is equal to a times this set -3, so it's x opposite plus 3, double root makes it squared. At 0, I just get x, and then over here we have a single root, which is x minus 3. Now, I know, and usually you'll see these rearranged, just so that if there's an x term by itself, I'm just going to move it out to the front. So I want to look at something that has this form, and x plus 3 is squared, x minus 3, and the a being negative. So x plus 3 squared, then we have, let me check this real quick. Let me take this sheet here. So this is the one we have. I think I had a correction on that one when I did it. So we had x plus 3 squared x, and again I'm going to rearrange it. Y equals ax, x plus 3 squared times x minus 3. We look for a is negative. So if I look at these, okay, we have the x minus 3 squared. That's not correct. Then we have this one. Well, the a value is not negative, and these guys are in the correct kind of a format, except that it's a wrong square. This one has the x plus 3 squared, okay, x minus 3, the x, and a negative. Okay, so C works. Now I got to figure out if either one of the D or the E's work. Well, right here, this guy factors to negative x, whoops. We have the negative x minus 3, then that's x plus 3 times x plus 3. So I have negative x minus 3 times x plus 3 squared, but I don't have an x. So that one doesn't work. Okay, this one's a little bit trickier. I can factor out an x. This one factors to 3 minus x times 3 plus x. Well, x plus 3 and x plus 3 are the same. So I can rewrite that as x plus 3 squared. 3 minus x is the same thing as negative 1 times x minus 3. And that's the tricky part. That does fit my criteria. So it ends up being E. Okay, on 14. Want to find the area of the triangle. So remember, what you need to get for area is side, angle, side. You can only use 1/2 base times height if you have a right triangle. And the formula is 1/2 AB sine of C. A and B are the two sides. C would be the angle between them. So I'm looking for side angle side. So if I look at this, I could use the 7 and 8 with the 105, the 7 and 12 with the 40, or I could figure out my missing one, which I should automatically do. 105 plus 40, that's 145. If I subtract that from 180, the missing angle here is 35. So if I use the 35, I'm going to use 1/2 8 times 12. Okay, so this one doesn't work because I need to have sine of the angle between them. 1/2 7 times 12 needs to be 40. That one's gone. 105 1/2 7 times 8. 7 times 8 is 56. That didn't get multiplied by 1/2. On this one, we have 1/2 8 times 12. Well, 1/2 of 8 is 4 times 12 is 48. Sine of 35. That's the one that works. This other one, that's the law of cosines. It's not used to find area. Okay, so let's look at the number 15. On problem number 15, I'm just going to use this sheet. We have a circle, has a center at -3, 4, and is tangent to the y-axis. You should draw a picture so you get an idea of what's going on. So at -3, 4, so -1, 2, 3, up 4, 1, 2, 3, 4. That's my center. Then they say it's tangent to the y-axis, which means it touches at one point. That means the graph comes through and it touches just like this, which means my radius is 3. So it would actually come around like that. Okay. So if my center, we do the opposites. So it's going to be x plus 3 squared plus y minus 4 squared. And then my radius is 3. It's r squared, which equals 9. So I look for x plus 3 squared, y minus 4 squared, equaling 9. That was C.